watched 7 slides of silent movie. For these questions, I think it's more difficult, so I should attempt to explain it. Here we have to convert all the radical form. This is called the radical form. Right, we will attempt to convert all the radical forms into index form. This is called the index form. Before we apply other rules that we have learned in the chapter of indices. Right, so what you can do, the best way to deal with this sort of question is that just simplify whatever that's inside the bracket first. Okay, simplify whatever that's inside the bracket first. So square root 2 will be 2 to the power half. And this one here means it's 2 to the power 1/3. Cube root of 2 means 2 to the power 1/3. Okay, I'm going to write this here just in case some of you have forgotten. So square root a, it's a to the power half. And cube root a is a to the power 1/3. All right. Okay, so how about this? How do we convert it? Okay, 2 means 2 to the power 1, right? So if you were to apply this one, can you see that your n is your 6, your m is actually your 1. So this can be converted into 1 over 6. Okay, 1 over 6. So that will give me 2 to the power 1 over 6, bracket then to the power 5. Okay, here we need to apply another rule here. This rule that we are going to apply will be this. All right, so this will give me 2 to the power half times 3. Okay, it's half times 3. Yeah? So half times 3 will give you 3 over 2. Half, 1/3 times 4, 4 over 3. And divide by 1 over 6 times 5, 5 over 6. Okay. Oh, sorry. All right. So these first two terms, okay, if we were to remember what we wrote earlier on, we can apply this one. When you have the same base, you just add, and then it must be times, then you add the power. So that will give us 2 to the power of 3 over 2 plus 4/3. And here we're talking about division. So if it's division, then what do? We minus the power. So we bracket these two first, then we minus away 5 over 6. Right, so then you use a calculator to work this out. You get 2. So 2 to the power of 2 means 2 times 2, that gives you 4. Right. Now we can proceed to managing some complicated expressions. So even though it looks complicated, basically you're just applying the rules that we have learned in indices. And to go about doing this kind of complicated expressions, we would try to express the terms given in the as possible, the smallest possible base. What do I mean? For example, 9, right? We will try to write it as 3 squared. So 27 will be 3 cubed. For example, 216, okay, we can write it as 6 cubed. Or this number, let's say 64, right? We try to write it as 2 to the power of 6. Okay, this is what I mean by you express it as the smallest possible base. Okay, so if you look at 81, right, 81 is 3 to the power of 4. Now if you not too sure why is 81 3 to the power of 4, 81 is 9 times 9, right? And 9 is 3 to the power of 2. So that will give us 3 to the power of 2 plus 2. That gives us 3 to the power of 4. Okay, alternatively, you can use a calculator and do a trial and error. Just press 3 to the power of 1, you get 3, right? 3 to the power of 2, you get 9. 3 to the power of 3, you get 27. And then 3 to the power of 4, you get 81. Okay, so the first step is to decompose the term into smallest possible base. All right, so from here, the next step we have to apply will be this rule here. So if you want to do this chapter well, you have to memorize all the rules. Okay, memorize all the rules, then you can and use it effectively. So this will give us 4 times x, then 4 times 1. Don't forget to multiply every term. You have to multiply every term, so that will give us 4x plus 4. And that will give us 3 to the power of 2x times 2 times 2x, 4x, over, that will give us 2x plus 2. All right, okay. All right, so another thing that you have to take note is when you see a bracket here, this term here, right, we see a bracket. What actually it means when you convert the bracket to the operations, what it means is bracket is also operation. What it means is that if you convert brackets to, it means 3 times 3 to the power of 4x. This is what it means. So 3 means 3 to the power 1, right? Okay, so what we're going to do is that will give us 3 to the power of 4x plus 4, then plus 3 times 3 to the power of 4x, then over 3 to the power of x minus 2 times 3 to the power of 2x plus 2. Alright, I have to erase this part of the, because then we won't have enough space for the working. Okay, so let's continue. Alright, so we can simplify the denominator. This one you can apply this rule, same base times same base, and then if it's a to the power times a to the power n, then you just add the power. Right, so our denominator will be 3 to the power of x minus 2 plus 2x plus 2. So that gives us 3x. Okay, that gives us 3x. So this will be 3 to the power of 3x. All right. Okay, so for the numerator, right, for the numerator, I'm going to do, now, this is something that you have to learn. We know we can combine. You see, when we have a to the power m times a to the power n gives you a to the power m plus n, right? But if you are given a to the power m plus n, you must be able also to separate them into a to the power m, then times a to the power n. Can you see? You must be able to work forward, also be able to work backwards. Okay, this is very important skill. It's a very important skill that you have to learn in mathematics. Okay, learn how to go forward, also learn how to go backward. So therefore, this case here, I'm going to break it up into 3 to the power of 4x times 3 to the power of 4. Alright, the reason is because we are going to extract this common factor out. So we take out this common factor. Right, so I'm left 3 to the power of 4 plus 3. And over 3 to the power of 3x. Okay, I'll continue the next slide. So what we have from the previous slides is 3 to the power 4 x bracket 3 to the power 4 plus 3 over 3 to the power 3x. Alright, there are two things we can do here. The first one is you can actually use a calculator to evaluate this. Then the second one is that we can simplify this. Alright, using a to the power m over a to the power n, that gives you a to the power m minus n. Alright, so let's continue. So this will give us 4 to the power 4x minus 3x. If we use a calculator to work it out, 3 to the power 4 plus 3, that gives you 84. So what you get is 3 to the power x times 84. Which is rearranging it because you are supposed to leave your answer as a times b to the power x. So you put the number first and then followed by your 3 to the power x. So that is the answer. Continue. We have managed to find the value for the left hand side in part 1 to be 84 times 3 to the power x. So we can equate it to 28, and I'm going to convert this bracket to times 3 to the power y. Alright, so what we're going to do is we're going to group the numbers together and then group the 3 to the power x and 3 to the power y together. So how do we do it? So I'm just going to divide by 28 times 3 to the power x on both sides. Okay, so on the left hand side, I'll be left with 84 over 28. On the right hand side, I'll be left with 3 to the power y over 3 to the power x. And 84 divided by 28, if you use a calculator, is actually 3. And this one here, okay, we can use the formula to get a to the power m minus n. So that will give us 3 to the power y minus x. And 3 is 3 to the power 1. So if they have the same base, right, same base, then we can conclude that the power would also be the same. And from there, we can make y the subject, which is 1 plus x, which is what the questions want us to show.